Hello everyone, welcome back to the channel. Today we are doing Leetcode 1695 maximum erasure value. So let's see what the problem statement says. It says you're given an array of positive integer nums and what you want to do is you want to erase a subarray. Now the only condition which you are given is that that particular subarray should contain unique elements. So for example, if I'm choosing XYZ, this as a subarray from a larger original array ABC XYZ, then these three elements should be, all of them should be different as compared to one another. Okay, 1 2 3 for example, the score you get by erasing the subarray is equal to the sum of its elements, right? Now the purpose of this question is, the ultimate goal that we want to achieve is return the maximum score you can get by erasing exactly one subarray. So if we think about it, we don't actually have to erase any subarray, we just have to find the subarray which gives us what, which gives us the maximum score. And how can we maximize the score? we basically need to see we basically need to find that one subarray which gives us the highest sum, you see, which gives us the highest sum, all the while maintaining this particular property. All right, for example, if I look at this particular test case, all right, let's say I start my window from over here. Right now the sum of my window is what, it's 4. I extend my window, it becomes equals to 6. But then when I expand my window further, the sum becomes 10, but then now my window is invalid because it's no longer obeying this particular property. 4 is being repeated, isn't it? I want to make sure that whatever my current window is, whatever are the current elements that I have chosen as part of the subarray, they are all different from one another. So now what this is telling me basically is I need to do what? I need to keep track of what I have seen, isn't it? I need to keep track of what I have seen. Whenever we need to keep track of things, for example, whenever we need to take into consideration the frequency of something, or the you can say the availability of something, whether it's present or not inside an array, what do? We either go with a map or we go with a set data structure, right? And what we are going to do is we are going to try both of them in today's problem. Now the problem over here is, you see, when I started my procedure, I had only taken 4 into account. 4's frequency was 1. I expanded my window, then 2 also got introduced and the sum was 6. But then when I try to further expand my window, I see that okay, 4 is being repeated. 4 is being repeated. So what I'm going to do is I'm going to erase 4 from my window. Okay, I'm going to erase this particular 4 from my window so that its frequency remains 1. And you would notice one very interesting thing, that the sum did not change at all. It was 6 previously due to this 4 2. Right now it's also 6 because 2 plus 4 is 6, right? Then I continue expanding my window. 5 is not there in the map, I'm seeing it for the first time, so I'll put it in my map. Similarly, 6 is something that I haven't seen previously, so I'll include it in my window. And I actually forgot to add the 5 over here, 11 and then 17. So this is basically the largest subarray that I can erase and get the maximum score out of. Now before we actually move on to the other example, this particular one, let me tell you a very interesting test case, right? Or maybe let's keep that for later. Let's start from here. So what I'll do is I will create a sum variable which is initialized to 0 and also an answer variable which is initialized to 0. Now why am I taking this particular variable? I'm taking this particular variable so that if, for example, my sum becomes less than what it was previously, right? Okay, so how can my sum become less than what it was previously? Because there are no negative integers, right? We'll come to that. We will come to that. But right now, let's just say that I'm taking this answer variable for a while. What I'll do is I'll start my window from over here. Right now, 5 is in my window. I will sort of, or let's say let's take a set. Okay, I am taking a set. I will put 5 inside my set. Perfect. Then I will see, okay, is there 2 inside the set? Have I seen it before? I haven't. So I'll include it over here. And I always forgot to do this, 5 and then 7. Then one, have I seen one before? I haven't. So I'll just put it into this particular set and I will update my sum. All right. Have I seen this 5 before? Yes, I have seen it. Now, one very important thing, why have I said that we either take a map or a set? Because whenever we are looking up things, it gives us an O of one time complexity. I could have taken a vector as well, right? I could have taken a vector as well. But in the worst case, I would have had to search through the entire vector in order to see if I have an element present or not, right? So that's why I'm either taking a map, like in this particular example, and over here what I'm doing is I'm taking a set. All right. So since 5 is already present over here in the set, what I'm going to do is I am going to erase this particular 5 from the window. Okay. So this 5 is no longer there in my window. Now, since this 5 is no longer there in my window, my sum should decrease, but it's not going to decrease. Why? Because this 5 just exited the window. It was thrown out, it was kicked out, but then this one also got introduced, right? So plus 5 and minus 5, the net result, the net change to my sum is 0. I hope you get my point, right? Then I expand my window. I sort of try to maximize my score, achieve my ultimate purpose. But then you see, 2 is still there in the set. 2 is still there in the set. So again, what I'll have to do is I will have to kick out this particular 2. Similarly, 1 is already there. So what I will have to do is I will have to kick out this particular one, so on and so forth, right? I kick out this particular one, then I try to expand. Now, this is a very interesting test case. Very interesting point. You see, 2 is actually repeating. I need to erase this 2. I need to kick out this particular 2 from my window. But what I will have to do as a result, in order to remove this 2, I will have to first kick out this 5 as well. You see, I will have to first kick out this 5 as well. This was my initial window. Okay, 5 to 1. This was my initial window just some time ago. Now 2 is repeating. So what I will have to do is, first of all, I will have to kick the 5 out of the window and then the 2 out of the window. So you see, since I'm kicking out 5 out of the window, I will have to erase it from the set. And since I erase 5 from the set, I will have to decrement my sum by 5. So it becomes 3. And it becomes 3 very correctly. Why? Because the sum of the current window is 1 plus 2, which is equal to 3, right? Perfect. Then I try to again maximize my window. Have I seen 5 before? In this particular window, I haven't. So what I'll do is I will put it into the set. I will increment my answer by 5. So it becomes 8. Now, I didn't actually do anything with this answer variable, but then the only point of taking this answer variable is to keep track of what the largest value of what the largest value you can say what was the largest state of sum. Okay, the largest value of sum, right? Perfect. So this particular thing is what I was trying to tell you through another example test case. And let me actually take let me 4 to 4 5 6, right? So I have 4 to 4 5 6. Let me give you again a very good example over here. So let's say I have 10 11 over here, let's say. All right. Now, if I try to do my working on this particular test case, what I will do is I will create a window. Now, over here in both of these examples, we were talking about windows, but we didn't really talk about how we are going to implement that window inside of our code, right? Like even from an architectural point of view, how do you actually do that? Right? Technically, how do you do that? So what I'm going to do is I'm going to take an I pointer and I'm going to take a j pointer. Now, the elements which are between I and j are part of my window. Others aren't. So right now my window has nothing. My window is empty, right? So I'll just keep a variable over here which is initialized to 0. My window has nothing right now. What I will do is I will take a set. And I will see, okay, is you can say, is nums of j, have I seen nums of j before? Is it present inside the set? It is not. It is clearly not present. So what I'll do is I'll put it into the set in order to keep keep track of it, I will include it in my window. Okay, and since I include it in my window, the sum is now going to become equals to 10. Perfect. Have I seen 11? Have I seen nums of 1? No. Keep it into my set, include it into my window. Perfect. Becomes 21. Have I seen 4? I haven't. So I'll put it into my set. I will increase it by 4. Have I seen 2? I haven't. I'll put it into the set. I will increment this by 2. Now, have I seen 4? Yes, I have. So since this is my window, I have seen 4 over here, isn't it? So what I need to do is I need to make sure that 4 is kicked out of the window. Now, in order to kick out 4, since we are dealing in terms of subarrays, I will have to kick out, you guessed it very correctly, I will have to kick out the 10 and the 11 as well. So first I will kick out the 10 by incrementing I, right? So I won't actually increment my I first. First of all, what I will do is, from inside my sum, I will say, okay, please subtract nums of I. And why are we subtracting nums of I? Because we are kicking it out. Why are we kicking it out? Because we have to shrink our window. Why are we shrinking our window? Because of duplication, right? So I first of all decrement by sum by 10, it becomes 17. Meanwhile, what I'll do is I will make sure that I track the highest value 27 inside of my answer. Okay, I will increment it. Now, how long should I shrink my window for? Until and unless this 4 is kicked out. Until and unless this 4 is kicked out. Now, have I reached 4? I need to kick out 4, right? Because that's what's causing the error. That is what is making my particular subarray disobey the only rule that we have to follow. So is this element 4? It's very clearly not. Again, I will decrement my sum by 11. What remains is 6, basically this 4 and 2, right? And I will increment my I. Now, have I reached 4? Yes, I have. Perfect. At this point, what I'll do is I'll no longer touch my sum, but I'll just increment I. Why? Because this was my window, right? Now what I'm doing is I'm just shifting it over here. So 4 plus 2 is actually equals to 2 plus 4, isn't it? Perfect. And I will have to remove the 10, 11, this one and this one from the set as well, because we have kicked them out, right? Why am I not erasing the 4? You already know the reason. Now, in hopes of again maximizing my answer, I'm going to expand my window. Have I seen 5? I haven't. Included in the set and count it in the sum. Have I seen 6? I haven't. I'll include it in the set and I will sort of increment my sum by 6. Then j goes out of bound, and that is the end of procedure. Overall, the highest subarray that I was able to find was it was this one, 10, 11, 4, 2, which gives you the sum of 27, right? So it's as simple as that. Now, throughout the explanation, I did not say we are doing sliding window. You saw how sliding window is helping me overcome this problem, isn't it? If you think about it, the brute force would have been that you calculate each and every subarray and you see which is the longest one. I should have actually started my discussion from that point, that the brute force of solving this particular problem would be that you think about all the subarrays that you possibly can arrange, and then you know what you do is you see which of the, you calculate the sum of each and every subarray one by one, and then you see which of them gives you the highest answer. But that would have been very clearly an O of n square operation in the worst case. What this is very clearly O of n, right? So we know where we are going with our approach in terms of time and space complexity. So how I can implement this is very simple. I'll just first of all calculate how many elements I have inside of nums, right? Perfect. Then what I'll do is I will take two pointers, I int j, and just like we said, we are going to take a set as well. I'm going to do the same problem with a map as well. It's going to be literally the same implementation, but a different data structure, right? What I'm going to do is I will have a while loop, and that while loop is going to end when j goes out of bound, just like we saw in the dry run of this particular test case. So right now my I is over here, my j is over here, right? Perfect. Now what I'm going to do is first of all see if I can expand my window. Expand window. So I'm going to say, okay, the current number. What's the current number? The current number is nums of j. All right, because j is the pointer. J is the pointer which we use to expand our window, and I is the pointer which we use to shrink the window. Keep this thing in mind. It's very important for you to know, right? So what we are doing is we are saying, okay, have you seen this current number before? Is it present in the set or not? If st dot find current number, if it's equal to st dot end, this particular line means that the number which you are currently standing at, it's not present in the set. Okay, not present in the set. What I'm going to do is I'm going to include it. In order to include it, I need to have two variables. First of all, a sum variable, which temporarily, which is acts sort of as a temporary variable, and then the answer variable, which keeps track of what? Which keeps track of the longest, not the longest actually. You can say the maximum score that I can get from any particular subarray that we have. What I will do is, if it's not present in the set, I need to include it. I will say sum plus equals what? Nums of j, or you can say current. Sum plus equals current, and you need to make sure that you insert the current number inside the set so that the next time you see it, you know that it's there in the current window. Perfect. Okay, now I include it in my sum. So what's going to happen is something like this. My sum becomes equals to 10, then I increment my j, isn't it? So what I'll do is I need to have an else over here as well, and that else will be that the number which I'm currently at is present in the set. All right, in the end, what I have to do is I have to do j plus plus. It doesn't matter if I find it, doesn't matter if I don't, I have to do j plus plus in both the scenarios, right? That's why it's out of the if else scope. Perfect. Then have I seen this 11 st dot find current? Is it present inside my set? It's not. It's just 10 which is there inside my set. So I'll add it to my sum, and it becomes 21. Similarly 4 I haven't seen. Similarly 2 I haven't seen. But then when I stumble upon this particular 4, I have seen this in my set. I have seen this in my set. So what I have to do is first of all erase all the numbers which are right. So until and unless I find 4 which is actually causing the problem, I have to keep shrinking my window. What I will say is, okay, while while nums of I while nums of I is not equal to something that's causing the error, which is 4. While nums of I is not equals to 4, just keep kicking things out of the window, right? While nums of I is not equals to current, keep kicking things out of the window. So what you do is, first of all, you say sum minus equals what? Sum minus equals nums of I. All right, and then you do I plus plus. So first you kick out, I had 27, right? I had 27. First you kick out this 10, it becomes 17, then you increment the window. Oh, sorry, then you increment your I pointer, shrink the window. Again, is this 4? No, it's not. First decrement this, becomes 6, then increment the I pointer, because if you increment the I pointer first, then you no longer have access to what this number was, isn't it? So you have to decrement the number first and then increment your I pointer. Now you have successfully reached this same number, isn't it? And just like we said, now what you have to do is you don't have to actually deal with sum, you just have to make sure that you get past that particular error causing number. So just move one step forward, move one step forward, one step, you can say, forward, right? So if you do that, you reach this particular point, and this 4 is kicked out of the window, right? Now I forgot this 10, 11, 4, 2. This must have been my set. When you kick 10 out of the window, you actually have to remove it from the set as well. All right, so make sure that you do that as well before you increment your I pointer. So you can say, okay, st dot erase whatever nums of I is, right? Whatever nums of I is. Perfect. st dot erase nums of I. Perfect. This looks good. And all the while you have to make sure that you keep track of what your maximum answer is. So answer is equals to maximum of what the current state of answer is, or what the current sum is, right? In the end, what you do is you just return the value of answer. That's it. So if we run it on the example test cases, let's see if they pass. They clearly do. And I hope all the other test cases pass as well, and they do as well, right? So now if we, again, we have talked about what the time and space, or what the time complexity is, but then if we analyze our code for the space complexity, it's very clearly O of n, right? We are taking a set, and we are storing the numbers inside of it. So in the worst case, what's going to happen is you have a very long array, right? And all of those numbers inside of that array are unique, so everything is going to be stored in the set, right? Now, just like I said, I'm going to implement it with a map as well. Let me do the necessary changes. What I'll have to do is just replace wherever there is st, I'll replace it with a map. So first place, then over here, rather than inserting it, what I'm going to do is I'm going to say, okay, mp of current plus plus. So, uh, increment its frequency. And if nums of I is not equal to current, sum minus equals this, and I'm going to say, okay, not st dot erase, but mp dot erase. So erase the key overall. All right, and that's it. If I submit this, it should get accepted. It should get accepted, hopefully. It does, right? So I hope you found the video helpful, and I will see you in the next one.